next problem statement is to implement Ackermann function using recursion. So Ackermann function is the fastest growing function and it is one of the best example for recursion. And the conditions for this Ackermann function are: if Ackermann function m comma n equal to n plus 1, if m value is 0, it is n plus 1 if m value is 0. If m is greater than 0 and n equal to 0, then Ackermann function of m minus 1 comma 1. And Ackermann function of m comma n, that is, if m value is greater than 0 and n value is greater than 0, then Ackermann of m minus 1 comma Ackermann of m comma n minus 1. So these are the conditions of the Ackermann function. And here we are going to use this header file, standard input-output header file. Next, this is a non-void function with parameters. Non-void function with parameters. So here the function name is ACK, that is Ackermann. Next, int p, int q are the identifiers. Next, here I am going to read the two numbers, m and n values, and here we are going to pass the function. So this is the function call, acc of m comma n. This is also an example for call by value as well. So we are directly calling the value. Next, Ackermann of, in the place of p we are substituting the value of m, in the place of q we are substituting value of n. Now if p is double equal to 0, that is n plus 1, right? N plus 1, here I am writing q plus 1. If q is double equal to 0, then Ackermann of p minus 1 comma 1, this is the value. Okay, else if q is equal to 0. Else, what is the last case? Ackermann of p minus 1 comma Ackermann of p comma q minus 1, if m is greater than 0 and n is greater than 0. So this is the Ackermann function. Now let us execute the code and check how we are going to get the value of this Ackermann function. Now let me give the values of m and n. I should give the value of m as, I am going to give the value of m as 0 and the value of n as 1. So the result of Ackermann function 0 and 1 is 2. Now let us see how we have got this Ackermann function value as 2. First, p, what is the value of m? M value is 0 and the n value is 1. Now I am passing to the function Ackermann of m comma n, that is 0 comma 1. Now p value is 0, q value is 1. Check the condition. If p is double equal to 0, return q plus 1. Now what is the value? Here the condition is true. P is double equal to 0, return q plus 1. Q plus 1 in the sense 1 plus 1, 2. We are returning 2 back to the function. That is the reason why we got the Ackermann function of 0 and 1 as 2. Directly we are giving the value. Let me execute once again with another test case. Let me give the value of m as 1 and n as 2. M as 1 and n as 2. So the result of Ackermann function 1 comma 2 is 4. So if we evaluate the internal steps of this, we will understand how your Ackermann function is giving you the result 4. Now let us execute this. Now let us understand the internal steps of this Ackermann function. Now the value of m and n are m equal to 1, n equal to 2. Now we are passing to the function Ackermann of 1 comma 2. Ackermann of 1 comma 2. Now p value is 1, q value is 2. Check the condition. If p is double equal to 0, that is 1 double equal to 0, condition is false. Then go for the else if. In else if what we have is q double equal to 0, this condition is also failed. Next, going to the last else part, return of Ackermann of p minus 1. What is p minus 1? P value is 1, 1 minus 1 is 0. Next, Ackermann of p, what is the p value? 1 comma q minus 1. 2 minus 1 is 1. So we got the Ackermann function as Ackermann of 0 comma Ackermann of 1 comma 1. Now there is a function call, that is a recursive function call. First we are going to call Ackermann of 1 comma 1. Now let me execute Ackermann of 1 comma 1. Now what is Ackermann of 1 comma 1 is, now p value is 1 and q value is 1. Let me just check the condition first. If p is double equal to 0, that is 1 is double equal to 0, condition is false. And the next one is q is double equal to 0, condition is failed. So here Ackermann of 1 comma 1, both if and else if are failed. Again we are going to the else part. Return of Ackermann of what is p minus 1? P minus 1 is 1 minus 1 is 0, comma Ackermann of p value. What is p value? 1, comma what is q minus 1? Q value is 1. 1 minus 1 is 0. Now we are going to call the function Ackermann of 1 comma 0. Now Ackermann of 1 comma 0, here p value equal to 1, q value equal to 0. Now check the condition. Is 1 double equal to 0? Condition is failed. Q double equal to 0? Condition is true. If condition is true, now in the else if part again we are going to call a function. So which function we are going to call now? Ackermann of p minus 1. What is p minus 1? P value is 1. 1 minus 1 is 0, comma what is the q value? 1. Now we are going to call the function Ackermann of 0 comma 1. Ackermann of 0 comma 1. So here p value is 0, q value is 1. Now if p double equal to 0, condition is true here. Now return q plus 1. Q value is already 1. 1 plus 1 is 2. Which means Ackermann of 0 1 will give the result of 2. Now this 2 we need to substitute in the place of Ackermann of 1 comma 0. In the place of Ackermann of 1 comma 0, we need to place the value of this 0 comma 1 value, whatever we have got it. Now 2 is substituted here. Next what is the value? 0 comma 2. 0 comma 2 whenever we substitute it. Now a value 0 comma 2. Ackermann of 0 comma 2. P value is 0, q value is 2. Again increment the q value by 1. Now q value equal to 3. This 3 we are going to give it to 3. We are going to substitute it to Ackermann of 1 comma 1. In the place of Ackermann of 1 comma 1, we are going to substitute 3. Which means now Ackermann of 0 comma 3. P equal to 0, q equal to 3. Now the condition is true. Now q value will become 4. Q value will become 4. So this is how the Ackermann function will give the value of 1 comma 2 as 4.